All right, that was my fellow physics teacher just came in and needed to borrow some equipment to take home. So that's why I had to stop it. But we're back. This is now we're going to divide. We multiplied in the previous video. Now we're going to divide. Okay, so dividing rational expressions. So we have these polynomials that we're dividing. So remember, when you divide something, you rewrite it as, so this part stays the same, 4 all over 15 n cubed, but that's going to be times, and you flip this one over. 25n all over 12. What I didn't write, I should have written this up first. If we had, and you don't have to write this down, a over b divided by c over d, that's the same as a over b times, you take the reciprocal of this, times d over c. And that's the goal, is to turn it into that. And then it's the same as the previous section. The previous, well, not section, the previous thing we did on the previous video. All right. So now that we have this, we're going to find any common factors and divide them out. All right. So the numerator is going to be 4 times 5 times 5. I know that it should be 2 times 2, but I'm going to leave it as a 4 just because I see where I'm going. Times n. There's that n right there. And in the denominator, this is going to be 3 times 5. And here's the 12 is going to be 3 times 4. And the reason why I did that is because I see a 4 here will cancel with that 4, and this 5 will cancel with one of these 5s. All right, and then we can't do anything with the 3s because there's no 3 up here. So, and I still have this n cubed, which n cubed, remember, is n times n squared. And again, the reason why I did that is because there's an n up here and there's an n, so an n down there. So I was looking for things in the numerator and denominator and trying to express them in the numerator and denominator so that they can cancel. I was just trying to make that somewhat obvious. 4 divided by 4 cancels. Again, this 4 came from 3 times 4 is 12. That's that 4. That 4 was this. Okay? And then we have a 5 right here, which comes from the 3 times 5. 5 is 15, that 5. And one of these 5s. 5 times 5 is 25. So you can cancel one of those. And then I have this n up here, and I have one of these n's, or this is n times n times n times n squared. And so those cancel. And now we write down whatever we have left, which is going to be, let me see, here's a 5 in the numerator. And the denominator, I have 3 times 3 is 9, n squared. And that does not simplify anymore. Okay. Dividing rational expressions. What else is in here? Let's try this one. We're still dividing. We've got 2 more examples I think I'll do. Maybe I'll skip that example and go with this one. Let's do a minus 2. I am on page 700. A minus 2 divided by 4a plus 4. 4a plus 4 divided by a plus 5 divided by a plus 1. Well, let's see what we can do here. I'm going to flip this over and multiply. So a minus 2, and then I'm going to skip a step. I'm going to flip it over and just directly multiply. So that's going to be a minus 2, a plus 1. I'm multiplying now instead of dividing, and so I flipped over this second fraction. And that's why the a plus 1 is up here, because I'm flipping over and multiplying. And here is 4a plus 4, that's that. And remember, I flipped over this second one and I'm multiplying, so that's this goes into the denominator. a plus 5. Well, hopefully you can see where we're going here. The only thing that has anything we can factor out is right here. We have a 4 here and a 4 here. So that's a minus 2, a plus 1. Factor out a 4 common to both of these. So that's, bring that out to the side. That's a plus 1, a plus 5. Again, what did I just do? First I flipped this over and multiplied. I factored out the 4 here to the side, because if I distribute it back in, that would be 4a. And 4 times 1 is 4. All right. And now the only we're looking in the numerator and denominator to see what's common, and what's common are those two. All right. So this becomes a minus 2 all over 4a plus 5. My excluded value would be negative 5, because if I put negative 5 in here, that would make that 0. You could probably leave it like that. You could also put a minus 2 divided by 4a plus 20, but I think let's leave it like that. And one more example. So let's just see what's happening here. This is the first day of spring break. I'm in here on Thursday, Holy Thursday. Thank you, God. Thank you, God, for having the classroom open. Last example is y minus 3 divided by y squared minus 10y plus 16 divided by y squared minus 9 all over y minus 8. Okay, so we know that we're going to flip over the second fraction and multiply. Just to save a little time, I'm going to factor as I go. So the numerator is going to stay the same. This is going to equal y minus 3. And I can put all these things on the same line since I am going to flip that over and multiply. So here's my y minus 8. Okay, I flipped over and multiplied instead of divided, flipped over that fraction. And this is going to factor to what? The factors for this are going to be negative what? Oh, negative 8 and negative 2, right? Got to think about that one. Because negative 8 times negative 2 is positive 16, and negative 8 plus negative 2 add up to negative 10. Okay. Whew. Sorry, it took a while. Doesn't matter what order, y minus 2, y minus 8. Again, I got that because negative 2 times negative 8 is positive 16. Again, I was looking for the factors of positive 16 that add up to negative 10. Negative 2 plus negative 8 add up to negative 10. And I still have this, right, because I flipped this over. And this is a difference between two perfect squares. Y squared is a perfect square, 9 is a perfect square. So that's going to be y minus 3, y plus 3. Again, it's the difference between two perfect squares. 9 is 3 squared. And of course, y squared is y squared. So the difference between two perfect squares. Okay. All right. So now we can factor anything that's common. We have a y minus 3 in parentheses here and a y minus 3 in parentheses there. So those factor out. And I have y minus 8 and y minus 8. Okay? So now we just write what's left, which is going to be 1 in the numerator divided by y minus 2, y plus 3. And we're done. If we ask for excluded values, set each of these terms equal to 0, the excluded value here would be y equals to positive 2, because 2 minus 2 is 0, and that was excluded, or negative 3. Those are excluded values. but we are finished with this section. All right.